We are going to continue our discussion of inverse functions by now looking at inverse tangent, inverse cotangent, inverse secant, and inverse cosecant. If you think about the fact that y is the sine of any given arc length or radian, and that the cosine of that arc length is x, then you would remember that tangent is y over x, cotangent is x over y. Then you can easily think about those domains. So tangent is going to have the same domain as sine, whereas inverse cotangent will have the same domain as cosine. We also need to think about the fact that if we look at the inverse secant of any particular value, we can take the inverse cosine of the reciprocal of that value. The same with the inverse cosecant, we can take the inverse sine of 1 over the value. We'll start here by doing a few problems. Remember that tangent is y over x, and secant in this case is going to be 1 over x. So the tangent, inverse tangent of 0. So I'm looking for a y over x value to be equal to 0, and I need it to occur somewhere from negative pi over 2 to positive pi over 2. So I will either have here negative 1 over 0, that's undefined. Here, 0 over 1, that's a possibility. Or here, 1 over 0. Well, it doesn't occur here and here because undefined is not equal to 0. So in this case, the inverse tangent of 0 must be 0 radians. Let's take a look at the next one, the inverse tangent of square root of 3. Again, I need to look from negative pi over 2 to pi over 2, and I'm dealing with things where I'm going to have the square root of 3. Now, if I remember that I've got y over x, I want square root of 3 to be in my numerator. So I'm going to pick the values where square root of 3 would end up being in the numerator. I also notice that this is positive, so I probably don't want the one where square root of 3 is negative. So just to check, I'll take a look at, pi over 3. So if I take square root of 3 over 2 divided by 1 over 2, that gives me square root of 3 over 2 times 2 over 1, and that is equal to square root of 3. So pi over 3 is the correct value. I'll now take a look at the last one, the inverse secant of square root of 2. I need to remember that secant is 1 over cosine, so the inverse secant would be essentially inverse 1 over cosine. Or I could look at this and say that I'm taking the inverse cosine of 1 over square root of 2. Well, I do know that we don't allow to have square root of 2 in the denominator, so I could multiply by square root of 2 over square root of 2, and that would give me square root of 2 over 2. Well, I can certainly find an inverse cosine of square root of 2 over 2. I remember that cosine needs to be located here. So my cosine of square root of 2 over 2 is right there at pi over 4. Taking a look at these next problems, they're going to be a little bit more of a challenge. But we will be able to use some Pythagorean identities to work through these. So for the first one, what I will do is I will let y equal the inverse cosecant of 13/12, which means that the cosecant of y is 13/12. What that also means is that I am taking the cotangent of y. This is a Pythagorean identity that I can work with because I know that 1 plus the cotangent squared of y is equal to the cosecant squared of y. And the cosecant squared of y I'll actually write this that the cotangent squared of y is equal to the cosecant squared of y, which is 13/12 squared minus 1. That gives me 25 1/44. And if I take the square root, the cotangent of y is equal to 5/12. Taking a look at the next problem, I'm going to take the inverse cosecant of the cosecant of negative 3 pi over 4. So if I start here, I go backwards 3 pi over 4. Here's 1 pi over 4, 2 pi over 4, negative 3 pi over 4 is here. Now remember that the inverse cosecant would just be the reciprocal of the sine. Well, sine is negative square root of 2 over 2. So the inverse cosecant here is negative 2 over the square root of 2. When we rationalize that, we multiply by square root of 2 over square root of 2. We get negative 2 root 2 over 2, which is really just negative square root of 2. Then what I do is I take the inverse cosecant of this, or I can take the inverse sine of negative 1 over the square root of 2, which I know is really negative square root of 2 over 2. So I'm looking somewhere where sine is allowed to exist for a y value that's negative square root of 2 over 2. That's here, so I'm looking at 7 pi over 4. Big problem. Can't have 7 pi over 4, so instead I need to make that a negative pi over 4. For this last problem, a problem that's this complicated, what I'm going to tell you is that you get to use your calculator. Be careful about where your parentheses go. But when you enter this in your calculator, you will get negative 1.824, and it will continue. What I want you to do after that is I want you to hit the button that says Math, and then I want you to select number 1, which is frac, and hit Enter. And that will give you an answer of negative 31/17.